let's start with a very basic concept of hypothesis testing. Now here the question is why we are learning hypothesis testing today. See, whenever we are learning data visualization, the first part that we have to understand how to frame a problem in order to find the statistical analysis. And the statistical analysis is very much related to this kind of hypothesis testing. So now first I will talk about how this hypothesis testing is related to real world activity and how we can understand that how to create the hypothesis testing problem in order to understand whether to accept that hypothesis or reject that hypothesis. So start from the very basic concept. Say if you ask me this question that why we need to use this hypothesis testing. One of the most important application of hypothesis testing is advertising spend calculation. Hypothesis tests are often used in business to determine whether or not some new advertisement campaigning or some market technique causes increased sales or not. So this is the problem. So try to understand this problem. Then from this problem, we will derive the problem of hypothesis testing. So today our problem is, say we are working on some advertising agency and here we have to make one hypothesis test in order to ensure whether a new advertising or digital marketing, anything you can say that, whatever campaigning they are using, it causes increased in sales or not. So this is the problem. So now we have to follow some test in hypothesis testing. So here how to frame this problem, that whether this business sales will increase or not. So what we will do, for an example, suppose a company believes that spending more money on digital advertising leads to increased sales. Right? Say there is one company and this company believes that if they use digital marketing scheme, then the sales will increase. Now to test this, the company may increase the money spent on digital advertising. Definitely if this is the belief, then definitely they will spend more money to this digital marketing, right? Now during 2 month period or more, then they will try to collect some data to see whether this sales increases or not. Means my point is they want to see that if overall sales have increased or not. Now here my point is, in this strategy how we can use the concept of hypothesis testing, right? So now in hypothesis testing we have two conventions. Means we can say that we have two hypotheses. One is known as H0 hypothesis and another one is known as HA or H1 hypothesis. Now this H0 hypothesis is known as null hypothesis. So here what we can write? Here we will frame the null hypothesis by writing this. Say mu after is equal to say mu before. Now first try to decode what is the meaning of this line. See, whenever I write mu, then you have to understand that I am talking about mean of the population. Means whenever we have many data sets or many data points, mu means the mean of the data points. So here the meaning of this line is the mean sales is same before and after spending more on advertising. So what is our null hypothesis? Here we believe that our mean sales is same before and after spending more on the advertising for the certain company. And for alternative hypothesis, I can write it like this. Mu after and mu before. So what is the meaning of this line? The mean sale increased after spending more on advertising. So here my point is, whenever a particular problem is given to you, first step is you have to find out what should be the statement for null hypothesis and what should be the statement for alternative hypothesis, right? So this is one problem formulation. Now try to understand if we have another problem. Say we have some kind of clinical trial activity. Say a problem is given to you as clinical trials. See, again, I can say that hypothesis tests are often used for clinical trial also. In order to determine whether some new treatment or some new drug, whatever is produced for the clinical trial, can cause improvement or can cause improved outcome for the patient or not. See, if this is the problem, then how can we frame the H0 and HA part? See, for an example, suppose a doctor believes that a new drug is able to reduce the blood pressure in obese patient, right? Now to test this, he may measure the blood pressure of say around 40 patients, and before and after using the drug for a month, then he will give the verdict. Now here the point is how we can design the hypothesis part. So what hypothesis test he has to perform? Again, we have two part, null hypothesis and alternative hypothesis. Now what is the statement for the null hypothesis? So I will write mu after equal to mu before. So I have already stated that I am using mu means whatever number of samples I am having, I am considering the sample mean. So what is the meaning of this line? That is, the mean blood pressure is same before and after taking the drug. So this is the null hypothesis. Now what is the alternative hypothesis? I can write mu after, say less than mu before. So what is the meaning of this? So the mean blood pressure is less than after using the drug. So this is the alternative hypothesis. So here I think the first point is clear. Whenever a certain problem is given to you, whether it is related to advertising, related to biology or related to clinical trial, in case of hypothesis testing, first we have to design the statement for null hypothesis and alternative hypothesis. So this is the first point, step number 1. Now after doing step number 1, what should be our step number 2? So what is this null hypothesis? What is this alternative hypothesis? What is the definition? I will tell you later on. But first try to understand how to design a hypothetical problem. Now step number 2, we have to consider two things. First part is known as p-value and the second part is known as significance level. This two part we have to understand. Sometimes this significance level is denoted as alpha. Now here, what is this p-value and what is this significance level? So I just want to tell you one point. Whenever you are designing any hypothesis testing problem, then the significance level you have to fix by yourself. Means this is some kind of threshold value. And what kind of value we will have? Generally, in maximum of the cases, the alpha value will be 0.05. So what is the meaning of this alpha value? I will tell you. But generally, alpha will be fixed as this particular value. But in some cases, you will find the alpha value as 0.01 also. But what is this p-value? Here the p-value is the test result that you are actually deriving. So basically you have to compare this p-value with the significance level. After comparing these two quantities or two parameters, then only you can tell that whether to accept null hypothesis or whether to accept alternative hypothesis. So here my first point is, whenever we are using hypothesis testing, we have to perform two straightforward steps. First, we have to design these statements. Then we have to fix the significance level. And then we have to find out or calculate the p-value with some algorithms. And then only we can give our verdict to accept or reject the null hypothesis or not. So this is the basic outline. Now, definitely, whenever I'm talking about this basic outline, then we have to understand meaning of each and everything that I'm stating right now. So here, if you ask me this question, okay, we have understood that H0 is known as null hypothesis. But what is the meaning of this null hypothesis? I can tell you one thing. The null hypothesis is commonly accepted fact. Right? So commonly accepted fact means you can say that it is the default fact. So this is the first term. Then I will elaborate it later. Then we have the alternative hypothesis that I have already stated, that HA or H1. That is, alternative hypothesis means that you will want to prove an alternative hypothesis. So this thing you are going to prove, or in simple word you can say that this alternative hypothesis is the opposite of null hypothesis. So whatever you are assuming in this null hypothesis, alternative hypothesis is just the opposite of this hypothesis. So here what happens, try to understand according to this definition. So I have already explained this problem, and you will find that whenever a problem statement regarding advertising or clinical trial is given to us, whatever hypothesis or whatever statement we made as a null hypothesis, it is the default thing. That particular clinical trial will improve the blood pressure or not. It will remain same. So the default assumptions will be the null hypothesis, and whatever we are assuming in H0, just the alternative fact we will consider here as alternative hypothesis. So this is the first part. Now I have already talked about there exists another parameter which is known as significance level, which is also known as alpha. Now if you ask me this question, what do you mean by alpha? I can say that it is a kind of probability. Now the question is, it's a probability of what? It defines the probability that the null hypothesis will be rejected. Means basically significance level defines the probability that the null hypothesis will be rejected. For an example, say a typical alpha value, I have already stated that generally we will write it as 0.05, or you can say this as 5% also. Both are same. Means writing alpha value 0.05 is same as writing alpha value 5%. Now what is the meaning of this line? See, if you see the alpha value as 0.05, then the meaning of this is there is 5% chance that you will find the support for the alternative hypothesis. Right? Try to understand. Whenever you are setting any alpha value like this, it is same as 1%. So what is the interpretation? Interpretation means that there is 1% chance that you will find a support for the alternative hypothesis. So this is the meaning of this significance level, right? So fixing up this null hypothesis value, either this value or this value, you can put anything, but generally people prefer to use this 0.05 level, right? So basically, when in truth the null hypothesis is actually true and you are going to reject it, it is a not right thing. So try to understand, depending on the significance level, you will find an evidence whether to reject this alternative hypothesis or support this alternative hypothesis, thus rejecting the null hypothesis. So here just make a note, whenever I am telling that there is a 5% chance of supporting the alternative hypothesis, it means I can say that there is another, means in reverse, we have the chance of rejecting the null hypothesis. Anyway, just think it like in one direction. So alpha significance level, whatever significance level is provided to you, it is a simple thing that you are getting the percentage of support for alternative hypothesis. So this is the first point. Now there is another thing associated with it, that is p-value. Now, what is this p-value? See, this p-value is another probability, but it is a calculated probability. Means it indicates the probability of achieving the result of the null hypothesis. So what is the meaning? Means how we can relate these two things. Means how we can conclude something from this alpha value and p-value. So it's a very straightforward. See, whatever value we have fixed up, we have to compare this value with the p-value. Means whatever calculated probability you are getting, always you have to make the comparison of this p-value with the significance level value in order to get some conclusion. So this is the first point you have to make a note. It's a very, very important thing that you have to remember. Now, what kind of conclusion we can get? It's an important thing. So I can tell you one point, just make a note. If you get high p-value, so whatever p-value you are getting, it is high, then you are likely with a true null. Means, see, we have already considered that if the p-value is high, then there are higher chances of the null hypothesis being true. So by visualizing the p-value, if it is higher than the significance level, then you can straight away say that there is a chance of the null hypothesis being true. So this conclusion you can make. So on the reverse hand, what we can say, if the p-value is low than the threshold or significance level, then it is more likely to reject the null hypothesis. So basically, high p-value means we are with the null hypothesis, and low p-value means we are likely to reject the null hypothesis. So this is the main consideration that we have to follow. But how they will work? This is the most important thing, because whenever I'm explaining each and every time, it will be bit confusing. But I'm giving you a very brief idea, just write it down. So how to compare? There is two specific statement. We will consider two values of p. First, we will try to compare whether the p-value is higher than alpha or whether the p-value is lower than alpha. These two things we have to check. Say, if whatever problem we are dealing with, we have got p-value which is higher than the significance level, then what you can conclude? See, if the p-value is high, it means there is a high chance of the null hypothesis is being true. Since it is the probability, p is not a value, it is the probability, that's why I'm stating that there is a high chance that whatever null hypothesis you have assumed, it is true for high p-value. Now, if you get p-value which is lower than the significance level, means low p-value. So from this what you can state? So from this you can state that if the p-value is low, then it is more likely to reject the null hypothesis. Means whatever statement you have assumed in null hypothesis, you have to reject it. There is no choice, right? So this is how you can conclude that whether to use these assumptions or whether to use these assumptions. See, for an advertising company, in the null hypothesis, you are just assuming that sales is increasing when we are using digital marketing. Means this is our consideration. So for a null hypothesis, I am just assuming sales will not increase. And alternative hypothesis is it will increase. The mean sales value will increase if you use digital marketing. Now, if I get a very high p-value than the significance level, it means I am supporting this null hypothesis. Means what was our statement? Our statement was the sales remained same before and after doing the digital marketing. So I'm supporting this, right? So this is the point you have to remember. So here the question is how to achieve this p-value and what do you mean by data samples? So this thing we want to see. Now let's start. See, I have created this program sample. So what is this program sample? So before starting this programming, I want to tell you one point. We have to be very certain that we are learning data visualization. And as a part of data visualization, we are learning hypothesis testing. So basically, statistical hypothesis testing is our main concern. So now I will tell you that we have several hypothesis testing, means the purpose of the hypothesis testing are different for different scenario, right? So you have to be very clear. First thing, whenever you are doing one hypothesis testing, you are doing the hypothesis testing for what purpose? This is the most important thing. Now you can ask me one question, purpose means what? See, technically, whenever we are doing data visualization, the first and foremost purpose of doing hypothesis testing is to check the distribution of the data set. It is known as normality test. So for performing normality test, I can do this statistical hypothesis testing. The second purpose, for some kind of correlation test, we can do some kind of hypothesis testing. And there are other reasons also. So first, let's focus on these two. What do you mean by normality and what do you mean by correlation? So question was how to achieve p-value. And my answer is how to achieve p-value. In order to understand this statement, first you have to understand for what purpose you want to calculate the p-value. Is this for normality test or is this for correlation test? Now say we agreed on this. Say now we want to calculate the p-value for normality test, right? Now the first question will come in your mind. What do you mean by normal distribution? See, I can tell you one point. So whenever we have this kind of graph, bell curved shaped graph means the graph appears symmetrically. Means, say if this is the mean value, as many data as we have over here, the same number of data we have over here. So this is known as Gaussian distribution or normal distribution. But if I tell you this definition, it will not be clear. Means why it is known as normal distribution. See, I'm just giving you one simple example. I have already shown you how the curve of the normal distribution will look like. Just take one example. Consider one competitive test like SAT or UPSC, JEE Advanced, GRE. Say these are the competitive exam, right? So now here the normal distribution indicate what? Whenever we are talking about this examination, so we have to talk about the results. So now my question is whether the data of the result is normally distributed or not. So how we can analyze this? So in that case, I will tell you that, see, some students have scored some average marks or grade as C, while some amount of student have scored some grade B or D, and another smaller amount of student have scored F or A grade. So this type of inference are taken from some empirical formula of the normal distribution. Means if you understand the nature of the values, then only you can infer something. That's why here my point is, in order to perform data analysis, whatever data we are dealing with, they should be normally distributed. Means whatever mean value we are getting, we have equal number of data points in both the sides of the data set. So this is known as normal distribution. We expect that. So basically my point is, whenever we are performing data visualization, the first thing we have to realize that whatever data we have, means whatever data samples we have, how these data samples are distributed, and our basic expectation is the data should be distributed normally so that we could infer something. Because if we have lots of data, and from that data we are not be able to interpret some conclusion, then those data are not useful, right? So just make a note, whenever we are performing data visualization, our expectation is the distribution of the data should be bell curved, or it should be normally distributed. Why? So that we could infer some new thing or new insight from that data, right? Now here the question is, okay, we have understood what do you mean by normality test, but how to do this? So here the first mechanism is known as this name. See, Shapiro-Wilk test. Shapiro-Wilk test is applied on the data set in order to find the data distribution. So now let's talk about the data. See, these are the data points that we are having. Now see, the first thing is, if you visualize the data set, by only visualizing the data set, you cannot assume that what should be the distribution of this data set. In order to infer something from this data set, we have to find out the distribution of the data set. So that's why we are using one algorithm, that is Shapiro algorithm. So it is very easy to use in Python. Whatever data you are having, just read this data into a data variable and apply this algorithm on this set of data. So this variable is holding this data set. So I'm just applying this algorithm on this data. Now see what I'm just taking. It is basically calculating the p-value. If you are going to calculate this p-value to check distribution of the data set, then you have to use one algorithm, that is Shapiro-Wilk algorithm. So Shapiro-Wilk algorithm will give you a p-value. By visualizing that p-value, I can tell you that whether these data sets are distributed normally or not. Now here see, the significance level alpha is set as 0.05. So I have already stated that alpha must be decided prior to the programming. So here, if the p-value is greater than alpha, then we can say that the data set is distributed normally. It is also known as Gaussian distribution. Otherwise, it is not Gaussian. So now if you execute this code, what is the agenda of this code? Agenda of this code is to calculate the p-value. So whenever you calculate the p-value, you will find this p-value. And see, this p-value is greater than or less than the significance level. By checking that, you can tell these data sets are probably normally distributed. So it's a Gaussian distribution. So I think the first question is clear to you, how to calculate p-value. It depends on the purpose. So what purpose we are now talking about? The first purpose that we are talking about is about normality distribution, right? Now we have another consideration. Do not think that to check the distribution of the data set, we have only this algorithm, this Shapiro-Wilk. No, we have another algorithm, that is this one, D'Augustro's K-square test. This is another algorithm, but the purpose of the algorithm is same. It will check that whether whatever data we are having, they are distributed normally or not. So the only change is, instead of using this algorithm to find out p-value, you have to use this algorithm. So whenever you are just writing normal test, means which algorithm you are using this one, D'Augustos chi-square test algorithm. This algorithm is also used for normality or the distribution checking for a data set. Any algorithm you can choose. Also, we can make a statistical analysis that which algorithm is performing better for our data set, right? However, we have the third algorithm also. But now you have to check one point. In the exam, I will ask you one question, that is, for calculating p-value in order to test the distribution of the data set, we have three algorithms. First, second, and the third algorithm is known as Anderson's Darling test algorithm. Now, what is the difference between these three algorithms? See, whenever you are visualizing the first two algorithms, there is no difference in terms of output, right? Only the algorithm itself is different. But when you are testing the distribution of the data set using Anderson-Darling test algorithm, see what is the output you are getting. This thing is very much important, and if you compare this output with the output of the previous algorithm, then you will find what is the difference of this algorithm with the other two algorithm. Actually, here try to understand what it is using. This assumptions is based on that each sample are independent and they are identically distributed. So in this case, they are talking about each and every sample. So I will talk about this algorithm with more details, but try to understand whenever you want to test whether a data sample has Gaussian distribution or not, then you have three options. But among these three options, whenever you have a chance that to find out some observation for each and every sample. So in that case, probably this algorithm will work best. So whenever we discuss this algorithm, it will be clear to you. But for the time being, what is our today's conclusion? Whenever you want to find out any p-value for finding the data distribution, you have three options. So this is all about normality test. But see, I have already stated that we have another purpose, means we can find out or we can perform statistical hypothesis testing for correlation test also. Now you can ask me one question, what do you mean by correlation, right? So correlation is a very simple thing that I'm going to explain in the next class, but if I ask you this question, that what is the meaning, means by correlation analysis what we are going to find out. Now try to understand. See, we have a data set like this. It's a very popular data set, Irish data set. And in a data set, this columns are the features, means the property by which the last column, the species column, is classified. Means depending on this 4 value, I will mark it as Irish setosa. So basically for any data set, you will have probably two parts. One is the list of features or attribute and another one is the class, right? So correlation analysis is used to check whether each samples are independent or not and if they are identically distributed or not. So try to understand whenever we are talking about any feature, our expectation is both the features or all of the features will be independent to each other. If two features are dependent on each other, then this classification is very difficult. So why we need to do correlation analysis? In order to test whether whatever attributes are given for classification, each and every attributes are independent or not. It is a some kind of data independence test, right? And also by using correlation test, we can ensure two things, that each samples are independent and identically distributed. So I will tell you the details. So now let's try to understand what are the names. So whenever you want to perform correlation test on some particular data set, you have four algorithms: Pearson's algorithm, Spearman algorithm, Kendall's algorithm, and chi-squared algorithm. Right? You have the four algorithm, but purpose of the four algorithm is correlation test. Right? So today in the first class, what is my objective? I want to make it very clear that whenever we are talking about hypothesis testing, we don't understand that this statistical hypothesis testing will differ depending on our requirement. So please make a note, if you are performing hypothesis testing for checking data distribution, then you have these three algorithms. However, if you are going to design the hypothesis testing to perform some correlation analysis, then you have this four algorithms. So I think the purpose of different hypothesis algorithms are clear. So in the next class, I will tell you what are the different correlation analysis we can perform. But one thing, I just ensuring that if I ask you this question, okay, tell me what is the basic difference between these algorithms and the algorithms that I have used previously. By the simple observation, you can say that, see, here we have only one data set, right? For each and every case, we have one set of data sets. But see, for correlation analysis, correlation. So whenever we are talking about this term, minimum how many data sets there? This is one set, this is another set. See? So correlation means always we should have minimum two sets of data samples so that we could find out they are independent of each other or not. So in this case, see, we have two sets of data set and I'm going to find out correlation analysis. Correlation analysis means this set is independent of this set or not. So what I will do, if I am going to use Pearson correlation analysis, then I will use Pearson algorithm on this two data set to find out the p-value. Again the same concept, if p-value is greater than alpha, then probably they are independent, otherwise they are not. Similarly, same thing will happen for Spearman, Kendall and other algorithms. So I will explain it later on. But I think the basic concept of correlation is clear to you. Means just like average. If you want to find out average, minimum two numbers are required. So similarly for correlation analysis, minimum two sets of samples are required. You have to find out whether they are dependent or not. And one thing you have to realize that always in data science, our expectation is whatever features we are having, they should be independent of each other. Means if p-value is greater than the significance level, this is our expectation. Independent features are expected, dependent features are very bad. Right? So answer is here. How to calculate p-value in case of hypothesis? We have total discussed seven algorithm, I guess. Four algorithm for correlation analysis and three algorithm for finding the distribution of the data set. But the purpose of all the algorithms are same, that we have to calculate the p-value. And the basic structure is same. After calculating the p-value, we have to compare whether the p-value is greater than the significance level or not. So this is the basic structure of all the algorithms that we are discussing today.